My name is Mashrur Rashik, and I am a PhD candidate at the University of Massachusetts Amherst. I work with Dr. Narges Mahyar and Dr. Sarvghad at the HCI Viz Lab. I will present our DIS 2024 paper on Beyond Text and Speech in Conversational Agents, mapping the design space of avatars on behalf of my co-authors and collaborators Mahmood Jasim and Kostiantyn Kucher, and advisors Sarvghad and Narges Mahyar. Conversational agents are becoming commonplace in many domains, including banking, e-commerce, and healthcare. To facilitate transparent and contextual conversations between a user and an agent, and to create a more engaging dialogue, conversational agents often accompany an avatar. In the context of conversational agents, an avatar is a representation of the agent in a digital environment. There are a large variety of conversational agent avatars. The design of avatars varies from simple objects to robot-like, to animal-like, to human-like, that can be static or interactive. Prior works on conversational agents suggest that the design of conversational agent avatars impact users' perceived usefulness and trustworthiness of the agent. For instance, Liu et al. Has shown that the gender of the avatar impacts the user's perceived trustworthiness. An avatar's facial expression and posture may also influence a user's willingness to engage with the agent. Han et al. Found that human-like talking avatars increases the enjoyment in using the system and the intent to use it. Prior research on categorizing conversational agents categorized some specific aspects of conversational agents, such as the design differences between general or domain-specific agents, whether the agent can engage users in a single one-to-one or group conversation, and the length of the interaction. However, this work focuses on the computational aspects of conversational agent, and we still lack a comprehensive categorization of critical avatar design dimensions. In this work, we address this gap by mapping the current conversational agent avatar design space, cataloging existing conversational agents, and categorizing avatar design across various design dimensions. We compiled a database of 266 papers across 160 venues from the past 20 years. We performed keyword searches using chatbot and conversational agent. Our initial search resulted in 9,621 papers. Our final database consisted of a total of 266 conversational agent papers. The first author reviewed and coded 141 papers and randomly distributed the remaining to the other 5 members based on their availability. At the end of the coding process, we finalized 10 design dimensions in our categorization. We built an interactive browser to facilitate exploration and interaction with these dimensions and their interrelationships. We categorized the existing design space of avatars across 10 design dimensions: appearance, gender, motion, interaction, dimensionality, input modality, conversation type, type of device, number of agents, and application. We refer to appearance as the external look that constitutes the manifestation of a conversational agent's visual features. Many chatbot avatars represent a variety of genders through their physical manifestation. Due to the complexities that gender categorization might introduce, we followed the gender that has been reported specifically by the respective authors in their published papers. We refer to motion as the visual representation of movement in avatars. We consider interaction as the manipulation of avatars via user inputs such as mouse hover, click, and keyboard entry. We attribute dimensionality as the number of planar dimensions across avatar's height, width, or depth. We refer to input modality as the mechanism used by conversational agent system to facilitate communication between the user and the agent. We use conversation type to refer to the form of conversation that takes place between a user and an agent. We considered type of device based on the devices supported by the conversational agent. We refer to the number of agents as the number of distinguishable agents a system provides in a single conversation session. Finally, we refer to application as a context where a conversational agent is expected to run, survive, and serve users. These design dimensions are an initial step towards mapping the design space of avatars, and they may evolve through future research in this area. To analyze the temporal trends across the design dimensions, we plotted a series of normalized stacked bar charts based on the percentage constitution of the subcategories over time. To highlight the correlation among the subcategories of our design dimensions, we also calculated the Pearson's correlation between them and created a confusion matrix heat map. We observed an incremental usage of robotic avatar appearance with a peak of 57.6% in 2021 and neutral gender with a peak of 51.1% in 2020. For instance, Shannon et al. Created an agent with robotic appearance and neutral gender to converse on financial and household issues. We observed an upward trend in using chatbots that are static with an average of 70% from 2015 to 2023. Recent studies have opted for static avatars due to their lack of animation, which tends to reduce cognitive load. We also found an increased usage of text input modality with an average of 63%. Prior research suggests that text input modality tends to improve the dialog processing speed. Our Pearson's correlation heat map revealed relationship among avatar appearance, dimensionality, and motion. We observed that static avatars are positively correlated with robot appearance and 2D dimensionality. Animated avatars, on the other hand, are positively correlated with human-like appearance and 3D dimensionality. Animated human-like avatars were found to create higher levels of engagement and elicit rich information in prior works. We found that animated and 3D avatars have a positive correlation with voice input modality and a negative correlation with text input modality. This observation is supported by prior research, which showed that animated and 3D avatars frequently co-occur with voice input modality to provide users with natural conversation experience. In addition to identifying common trends and patterns, we also identified gaps in avatar design. Our stacked bar chart shows web application as the most frequently used device for conversational agent interaction. Yet we found no significant correlation between web application and other design dimensions. This shows an overview of the interactive browser. A side panel displays the number of papers followed by an array of filters. Each thumbnail functions as an interactive button, which reveals details about the corresponding item. At the top, a navigation bar provides an access to an array of options, including the summary dialog box and the heat map visualization. The implications of a categorization are multifaceted, including identifying emerging design trends, discerning relationships between the design dimensions, exploring novel combinations of the design dimensions, and informing future avatar design strategies. Our work contributes a foundation for researchers, designers, and practitioners to identify critical design aspects, discern relationships between them, and experiment with novel combinations of the various aspects that can support avatar design based on different contexts. Thank you.